Alright, so in this video we're going to talk about the derivatives of the rest of the trig functions. So in the last video we determined that, let's see here. Yes, we determined that the derivative of sine of x is equal to cosine of x. Now similarly, using the same derivation method, using the limit definition of the derivative, we would find that the derivative of cosine of x is equal to negative sine of x. Okay, and these are the two most important derivatives of the trigonometric functions, so you'll want to memorize those. Now, using these and the rules for taking derivatives that we learned in the last couple of videos, we can actually derive some of the other derivatives. So suppose we were to take the derivative of the tangent of x. Well, this is the same thing as taking their derivative of sine of x over cosine of x, right? Which is just quotient rule. Okay, and remembering quotient rule, we have the derivative of the first, which is sine of x, so the derivative of sine is cosine. So we have cosine of x times, so the derivative of the first times the second times cosine of x minus the first sine of x times the derivative of the second, which is actually negative sine of x. Okay, then we divide that by the bottom squared, which is cosine squared. And that'll give us, let's see here, the first term will be 1. We have cosine squared over cosine squared, and the second term will be positive sine squared over cosine squared. So plus positive sine squared over cosine squared. So that's plus tangent squared of x, which, if you will remember your trig identities, this is equal to secant squared, where 1 plus tan squared equals secant squared, or secant squared minus 1 equals tan squared. So secant squared of x minus 1 equals tan squared. So using this identity, we can derive that 1 plus tan squared is equal to secant squared of x. Okay, and that is the derivative of tangent of x. Okay, go ahead and box the rest of these in. Alright, so that's another important one. We want to memorize that. So the next one we can do is cotangent of x. So we have d over dx of cotangent of x. And with this one, you can actually prove it in the exact same way using using quotient rule if you would like to, but I'm going to go ahead and just give it to you and get negative cosecant squared of x. Okay. Again, these are all ones that you're going to want to memorize. Okay, next, the derivative of secant of x. Well, secant is just 1 over cosine of x, and so again you could use quotient rule to find that this is equal to secant of x times the tangent of x. And the last one, which is cosecant of x. So let's go ahead and star this one as well. So the derivative of cosecant of x is equal to negative cosecant of x cotangent of x. Now, I would say for practice, it would probably be a good idea to go ahead and try to derive all of these on your own, but I'm going to go ahead and just give them all to you like this. So we have d over dx of sine x, or the derivative of sine is cosine, derivative of cosine is negative sine, and then using those two derivatives we can find the rest. Now, another interesting thing to do would be to take the second derivatives of all of these. So the derivative of cosine, the second derivative of sine, in this case, would be d squared over dx squared of sine of x. That would just be equal to the first derivative of cosine, since cosine is the first derivative of sine. So taking the second derivative of sine would just be negative sine of x, right? And this is the cool thing about trigonometric functions, is they just take this alternating pattern like this. So similarly, if we took the second derivative of cosine, we would get the first derivative of sine times -1, which is negative cosine. And again, I would say that this is good practice. If you wanted to, you could go through all of these and take the second derivatives and see what you get. That would be good practice. Anyway, we'll see you in the next video.